So we've talked briefly already about the change in momentum. This video is going to talk about impulse, which is a fancy way of saying the change in momentum. So let's dig a little bit deeper into this. All right, I want to start with Newton's second law, where we say that the net force is equal to the mass times acceleration. All right, acceleration in this class at least, we talk about it as being a constant. It doesn't change. And so the instantaneous acceleration is going to be the same as the average acceleration, or the change in velocity over the change in time. And so I can substitute that in right here. So the net force is actually just the mass times the change in velocity over the change in time. This should look sort of familiar. This m times delta v, that is the change in momentum. So if we solve for that by just multiplying both sides by delta t, we get m delta v, or the change in momentum, is equal to the net force times the change in time. This is what we call the impulse momentum theorem. You will see it like this, or you might see it as just F net delta t equals m delta v. Now, what is impulse? Impulse is just a force imparted over time. In some physics classes, you might see it given the letter, of course, not I, because I means something else. I is rotational inertia, or the moment of inertia. So impulse is actually given the letter J. In AP Physics, though, we just talk about impulse as being the change in momentum, or delta P. The change in momentum, the impulse, has units of newtons, that's the force, times units of time, or seconds. And so you might also see momentum given the unit of newtons times seconds as compared to kilograms times meters per second. So either of these units, they're pretty much interchangeable for both momentum and for impulse. All right, so impulse is just the change in momentum. It is the force times the time. And so if I were to graph the force on an object over the amount of time, and let's say I get something that looks like this, it's a little funky. The force is in one direction, and then it's in the other direction. It increases and then decreases. The area under this curve on this force versus time graph will give us our impulse. So positive areas will give us positive impulses, and negative areas will give us negative impulses, or negative changes in momentum. So let's talk about impulse and momentum and forces when we have somebody throwing an object and somebody catching an object. And let's talk about this as being an egg, right? I think that in a lot of family picnics or barbecues, field days, you might have experienced the egg toss, where one person throws an egg and the other person catches it, and then they step back and then they throw and catch again. And the whole goal is to not have the egg break. And in comes this idea of soft hands, right? That when you catch that egg, you don't want to just catch it, but you want to catch it and move your hands with it. Because if the egg just lands in your hand, there's a lot of force there. And so the question is, why, when you just have your hands still, does the egg break? Why is there a lot of force? Versus if I do this to catch it, why does the egg not break? And so this person throws this egg and this person catches the egg. And there are a few things that I want to talk about before we really get into that idea of force. Who imparts a greater change in momentum? Or the way it might be asked is, who gives a larger impulse? So the mass of the egg, you think the change in momentum, delta P, is m delta V. The mass of the egg doesn't change, And the change in velocity, one person increases the velocity by a certain amount and one person decreases the velocity by a certain amount. And so the change in momentum that these two people impart, let's say the boy and the girl, the change in momentum, the impulse will be the same. Okay, the next question takes us back to the previous unit. Who does more work on the egg? So when you're thinking about this, I know you probably went to work is force times distance. Do you know who imparts a greater force? Yeah, we haven't talked about who does that either. But the key here isn't using this definition for work, but using the work kinetic energy theorem, where work is the change in kinetic energy, or 1/2 m change in velocity squared. And so if we think about work this way, well, both people, the mass of the egg is the same and the change in velocity of the egg will be the same. One person speeds it up, the other person slows it down. And so who does more work on the egg? They also do the same amount of work. So the impulse is the same and the work is the same. And then who imparts a greater force? Like, how do we get that question? There's two ways to know. We can talk about it via work. If we knew the distance that this person's arm traveled during throwing it and the distance that this person's arm traveled while catching it, we might be able to find the force using work. The other way to think about it, or the other way to look at this, is the time that these two people are in contact with the egg. So if the change in momentum is the same, force times the change in time, if this is to be a constant, the greater the time, the smaller the force. And so really we can't determine the force using momentum and impulse without first knowing how much time. But because the change in momentum is going to be the same, you have the same initial velocity, maybe that velocity is 5 meters per second, the change in momentum will stay the same. And so by increasing the amount of time that you are in contact with that object, that will then in turn decrease the force. This is why airbags work. So think you're in a car wreck, you hit the wall, the airbag doesn't change your initial velocity, it doesn't change your final velocity, so it doesn't change your momentum change, it doesn't change your impulse, but it does change the amount of time that you are experiencing that force. So by changing the amount of time, by giving your face or your chest a cushion to hit, you are then making the force that you feel less.